Hey guys, here's part C and D of chapter 1, chapter 17, AP problem number 1. So for letter C it says 1.2 molar. Ooh, yeah, no, this is it. Solution is prepared by dissolving sodium hypochlorite in distilled water, 298. Okay, so write the equilibrium constant expression. So that means K that we're writing here, but because this is an OH there, it should be a KB for base. So we're going to do what we've always done. We don't write that because it's a pure substance. We write everything else though, products over reactants, which means HOCl times the concentration of OH minus, all divided by OCl negative, like that. Okay, so the question then becomes, remember we don't write H2O because that's a pure substance, then becomes what to calculate the value of the equilibrium constant. That means we're looking for the KB. Well, here's what we do know. We do know that Kw equals Ka times Kb. So that means if I'm solving for Kb, I'm going to divide both sides by Ka, which is where I get the equation Kb equals Kw divided by Ka of the same system. We do have, by same system, I mean here's the Ka of HOCl. So we all know what Kw is. That's 1 times 10 to the negative 14th divided by 2.9 times 10 to the negative 8th. When I divide those two, I get 3.4 times 10 to the negative 7th. Okay, so there's my Kb. Now here it says calculate the value of OH. Now this is still the same thing. I'm going to rewrite it with water like this. This is the same as it was before, OH minus. That's because once I find the concentration of weak acid or weak base, then I've got to use my ice chart. 1.20000. This one doesn't even show up, so it's a minus x plus x plus x. This is 1.2 minus x, but because of the 5% rule, we can just ignore that, and that is x and x. Kb we know is 3.4 times 10 to the negative 7th. We just found that. And that equals, and then HOCl, OH minus, all divided by OCl minus, like that. When I substitute in, I get x and x over 1.2 equals 3.4 times 10 to the negative 7th. I'm going to multiply both sides by 1.2. Now when I multiply both sides by 1.2, I get 4.08 times 10 to the negative 7th, and that equals x squared. So I take the square root of both of them, like that. X equals 6. Actually ends up being 3.7 or something like that, but we'll round off to 4 times 10 to the negative 4th. This is our concentration, like that. So it says calculate the value of concentration of OH minus. A buffer solution is prepared by dissolving some of the solid blah, blah, blah. Okay, so let's keep going, see if we can figure this out. So the pH is determined to be, so this is the easy one, pH equals 6.48, like that. That means that I take, so pH equals 10 to the negative 10 to the negative pH, like that. So if I want to know what the hydrogen ion concentration is, which is what this is asking for, it is equal to 10 to the negative 6.48, like that. And that equals 3.3 times 10 to the negative 7th molarity. Okay? So it says indicate which HOCl or the OCl minus is present in a higher concentration of the buffer solution, and support your answer with a calculation. Well, let's take a look if I look at the Ka like this, Ka is the H plus OCl minus all over Cl like that. Okay, we all know that this equals. So here, well, let's do this part first. We all know that this equals 2.9 times 10 to the negative 7th, like that. Negative 8th, bonehead. And that's the Ka. We know that 3.3 is the concentration, times 10 to the negative 7th here. We have our OCl minus, like that, divided by concentration of HOCl, like that. Now what if I divide both sides? What if I divide both sides by 3.3 times 10 to the negative 7th? What I end up with then is, now see if you can follow along with this. I need to move my screen down a little bit, get some room. If I divide both sides by 3.3 times 10 to the negative 7th, what I end up with then is 2.9 times 10 to the negative 8th divided by 3.3 times 10 to the negative 7th. Whatever that equals, it actually equals, if I do that, 0.088, and that equals OCl minus over HOCl, which means that if that's less than 1, then numerator is less, which means the concentration of HOCl is greater than the concentration of OCl minus. All right, I'll give you guys some time to digest that. I'll talk to you later. We're in good shape.